Okay, Jam. When was the last time you went to the dentist?
Ooh, do you want me to tell you really for real?
No, it's okay. Have you ever had a cavity filled?
Yes, I have. I've had many a cavity filled.
Okay. Have you ever wondered what's in those cavities?
What's in the cavities or
When
what's
you
in the
get
filling?
them filled. What's in the filling?
Yeah, I have wondered that.
Well, today we're going to talk about it.
Okay.
We're going to talk about some of the chemistry behind dentistry.
Nice.
Let's get into it.
Okay.
Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
And we're back in action.
Mm-hmm.
I don't know if you can tell by the sound of our voices, but Jim and I have not recorded together for over a month, I think. Or is it right at a month?
That's a good question. It might be easier to tell visually if you are watching on our YouTube channel. You might be like, from one episode to the next, they look pretty different or something like that. I don't know. Tell us if you can tell.
Yeah, the last time we recorded was July 16th, 17th.
Whoa.
And now it's late August. So
yeah,
we're back at it. And we're still in our late night schedule, which is even more challenging.
Chemistry at night.
Chemistry at night, chemistry after dark. And now this is a fun bit of exciting news. I recently joined the UNT chemistry department. So I'm now a lecturer at University of North Texas, and I teach at 8 a.m. every day. And we're doing chemistry. We're doing chemistry at night.
But at least you get to start the day with chemistry and end the day
that is
with chemistry.
So true.
You know, your day is just bookended early in the morning and late at night with chemistry.
Yeah, so it's just like I wake and sleep chemistry, right? Anyway, so if I have any big yawns, that's why. Okay, so also before we get started, I want to shout out, speaking of teaching, a former student of mine, Chelsea M, is now part of our community.
Yes, that is awesome.
I know, so exciting. And Dorian V is also part of our community. So we got 2 new community members while I was off on my travels and teaching. So that's very exciting. And I am also going to save this fun little tidbit about a tragic dental incident that occurred to me in the last month for the community episode. So if you're part of our community, you can hear about what inspired the episode that we're about to have right now.
Nice. Yeah. So those 2 folks who just joined our super cool Chem Community patrons, they get a bonus episode, our Chem Community episode once a month. They get an ad-free feed of the show. They get behind the scenes stuff. They get to message with us. They get to various perks depending on which tier they pick. Some of them get a monthly coffee hour where they get to hang out, virtual coffee hour. They hang out with us. Stickers. So anyway,
sometimes we just send Christmas cards because we think it's cute, or holiday cards. Last year we took selfies with an Instax and mailed them to people.
Yep. So it's a lot of fun, and obviously those perks are cool. We love doing that as a thank you because those folks who join our community help keep the show going and keep it free. And so thank you guys for joining. It's Dorian and Chelsea, right?
Yep. Dorian and Chelsea.
We are so glad to have you all as part of our Chem community. You too can join our community at patreon.com/chem for your life. I almost said our own website again. I keep doing that. Anyway, sorry. Now we can
get on the show. Maybe on YouTube I can send you a picture of my face swollen for the dental incident that inspired this, and that could be a good teaser for the community.
Let's do it.
Okay. So I totally lost my train of thought. Okay. Oh, one other thing is I met a lot of very cool listeners at BCCE.
Oh, yeah.
A conference I went to right before I went on my traveling adventures, and it was really fun, and I really enjoyed it. I'm going to shout out some by name, but I'll wait until next episode since I've just shouted out so many people. So much has happened in the last month. So, okay, great. So I just wanted to say that too.
Nice.
Now let's talk about dental fillings. Let's get into our chemistry lesson.
Okay.
This is my third chemistry lesson of the day. Fourth if you count office hours. So
Wow.
hopefully I'm not fresh, but hopefully I'm like finely tuned.
Yeah.
You
Nice.
know?
Nice. Yeah.
I've had my warm up. This is the real show. Okay, so our chemistry lesson for today, all about dental fillings. When you experience tooth decay, that's typically the result of acid that comes from bacteria that feeds on the food left behind in your teeth, which is gross if you think about it.
Right.
And if there's enough tooth decay, you may need a filling so that the decay will stop to sort of contain that. In my case, it needed a root canal. We'll talk about that later in the community. So to stop the decay from worsening, you can get a filling. And so I went in and got a filling, and I was in my chair, and I was in the dental chair, and I kept seeing them use a light and do some things. And I was like, what's happening? So, of course, I went and looked it up. Okay.
Yes.
And I'm going to share with you what I learned.
Okay.
And it's kind of like a fun few little chemistry lessons today.
Nice.
Dental fillings, modern dental fillings, are made up of a composite matrix with two primary things. There's some other things in there, but there's two main things in them.
Okay.
Do you have any guesses?
Two main things in there. So when you say main things, you're not talking about just elements. You're talking about like maybe
Materials.
like materials. Okay.
Yeah.
All right. Whoa. I don't even know where to start.
That's so exciting.
Yeah. I'm like I don't even know if I know what teeth are made out of. Have we ever talked about that before?
We have talked about it very briefly on the why fluoride's good for your teeth episode.
Oh, we did. Yeah, I remember that. Okay. I mean, I don't really remember it, but I remember that we did that.
Well, we're going to re-release it for next week, so you can revisit it, and so can our listeners.
Nice.
We also talked about why orange juice tastes so bad after you brush your teeth. So I'll just tell you,
Okay.
There's two things present primarily. There's some other stuff too, but the main things are organic molecules.
Okay.
They are single organic molecules that are designed to bond together and form a polymer.
Okay.
So we would call
Polymer would have been a
those-
great guess, huh?
Yeah,
Just
polymer would have been a
very
great guess.
generically. Yeah. Duh, of course.
And until today, I thought it was only polymer,
Okay.
but there's more in there than that.
Okay.
And so I'll say polymers, we've talked about them a lot on the podcast, but they're a large molecule that are made up of small repeating units. A good example is like I have a beaded necklace on. The repeating units of the beads is like, okay, every individual every individual molecule, they bond together to make one large molecule. That would be a polymer. Okay. And so these individual organic molecules that make up the polymer, we call them monomers. But initially, they're in like a liquidy state. They're not hardened into a solid polymer yet. They're just individual organic molecules hanging out separately. And after we put them in, then they form the polymer.
Okay.
Okay. And the other thing is inorganic materials, which we don't talk about very often, but non-carbon containing molecules.
Okay.
So this is usually going to be silica or some kind of silicon oxygen compound. So like ground really fine quartz or ground glass, because that's very hard.
Okay.
And that's actually the predominant thing present.
Right.
Okay. So those are the two main things. And I could just be like, and that's the chemistry, and there you go, and now you know. But I'm going to talk a little bit more about the details and why we need the two parts, and you can't just have all polymer. I'm very excited about this. Okay, so essentially what you do is you mix these organic molecules, the small molecules, in the organic ones in with the inorganic fillers. And they're still in that liquidy state. Nothing has bonded together. So it's just a bunch of individual molecules, not one big one.
Okay.
And that lets you fill in the dentist, not you, but the dentist fill in all the gaps where there was tooth decay, where you've drilled that out.
Right. So yeah, they have to get that fully removed first, right?
Yes.
Yeah.
They get the decay fully removed and they go in with this filling. And because it's not already hardened, it's in a liquidy state, they're able to sort of distribute the filler with the polymer makings without the actual polymer started yet.
Okay.
So like the ingredients for the polymer and the filler get distributed. They're more easy to distribute because they're in like a liquidy state.
Okay.
And then, or the polymer part is at least, and then they will initiate the polymer forming. So the polymer will harden, and we'll talk about how that happens in a little bit. The polymer will form, so all these individual molecules will actually start to bond together. So they start to share electrons is what happens. And as they're doing that, they're sort of going around that filler. So they're keeping the filler in place.
Okay. So those are like little like molecules of, what do you say, like quartz or silica or whatever?
Yeah.
They just get
little like very fine ground powder.
Fine. Okay.
Yeah.
And those don't bond with it. They just get entrapped around. Oh,
they do bond. They can get bonded to it, but you sometimes have to have a specific thing that will bond the polymer to the thing, to the inorganic filler. So we're not going to get into the details of that, but you can kind of think of the polymer as holding the filler in place.
Okay.
So the polymer makes the sort of matrix that holds that inorganic filler where it goes. Okay.
Yeah.
Okay, and you do that layer by layer. So sort of like when you're seasoning a cast iron pan and you do a polymer layer and then another polymer layer. So each one can harden fully and you can have a really good polymer coating. You do the same thing. You basically are a dentist when you're doing your cast iron coating.
I did not know that. I didn't know how good of a dentist I was.
Yeah, you didn't.
I'm a really good cast iron pan dentist.
Okay, I just want to say that dentists go to school for a really long time and they're doctors of a different kind than me, and we don't actually think we're dentists.
Yeah, definitely not. And I am grateful that they know what they're doing and that they learn so much. And yeah, I don't.
Me too.
No, it's no joke, but it's fun to make a joke, but it's not really a joke.
Okay, so that is the basic mechanics and the very basic chemistry of a dental filling. So if you're just in it for a short, quick chemistry lesson, what are we at? Like 10 minutes? That'll be good for you. And then you can dip out. But now I'm going to talk about why they don't just use only polymers.
Okay.
And why there's more going on. Okay. So, one polymer may not be hard enough. So those inorganic fillers they add some of the hardness and the ability to withstand the pressure, especially that you get towards the back teeth.
Oh, yeah.
Because there's a lot of pressure when you bite down.
Right.
But I'm going to start with an analogy for what happens when polymers actually polymerize. So imagine you have a group of people standing around chatting.
Okay.
These people are not touching. They're just a group of people. They're held together by a very casual interaction of chit chat, right? Now, if you asked all those people to link up arms, they would get a lot closer together, right? Because now there's a physical thing holding them together. They're not just casually interacting.
Right.
Okay, the same thing happens when individual molecules polymerize. So initially, molecules are all on their own.
Okay.
They're sort of grouped up together by these informal interactions, like casual conversation, that we would call intermolecular forces. So two molecules that come near each other will have some attraction between one another, but it's not like they're fully bonded. And when I say bonded, I mean their electrons are being shared between two atoms that make those molecules joined.
Okay.
It's just the molecules, they're kind of their own entity, but when they're near each other, they will kind of slightly be attracted to each other, kind of like magnets.
Okay.
So like they're two separate magnets, but they can be, attracted to one another.
Yeah.
Okay. So that's sort of the initial state when it's in the liquidy state.
Okay.
Is that all the molecules are there, they're casually interacting, but they're not fused together yet. Okay. And the thing is, if we just fused them together, they would get a lot closer and you would get some, what we call polymerization shrinkage. So as it polymerizes, the molecules are not just attracted by intermolecular forces anymore. They start to fuse together. They're sharing electrons and making full bonds. We'll talk about how that happens in a little bit. And as they do that, instead of just being like, okay, we're casually hanging out near each other, they start to actually come together and get a lot tighter. Just like that group of people that's linking up arms, as they physically are bonded together, they're going to be a much smaller, tighter knit group.
Yeah.
Which it's good sometimes for people to become tighter and closer knit. In this case, it's not good.
Right.
Because if they shrink as they become a polymer, then you can have a gap between the tooth and the filling, and then bacteria can get in and do the same thing. You can have more decay. Or if it's bonded to the tooth already and it starts to shrink, it can put stress on that tooth.
Yeah.
And
kind
it
of
can
pulling in, depending on how deep the kind of hole they had to drill or whatever. Yeah. Wow.
It can weaken the tooth, or the filling itself could crack.
Yeah.
Like it could be not set well. So basically the filling won't do its job, or it won't do its job for very long.
Yeah.
So what they did instead, I'm going to switch up our analogy a little bit.
Okay.
And I'm going to try to use something sort of different. Similar idea. Imagine now we're throwing an event, maybe to celebrate someone. And so we want to fill up the room, you know? The room is our cavity that we've drilled out. We want to fill the space up. We're trying to celebrate somebody. We're going to fill up the space. Okay. And then the guest of honor starts to give a speech. And so everybody draws in close to hear him. And you realize that there's still like half a room's worth of empty space.
Okay.
And the effect is a lot less positive.
Right.
Your room's not filled up anymore. So to solve this problem, what we could do is put tables and chairs out. So everybody sits down. You need less people to fill up the same amount of space, but the people are still there in the room.
Right.
There's just some structure around where they are.
Yeah, they're all surrounding the tables, and the tables are taking up space too.
Exactly.
Yeah, okay.
Okay, so that is what the inorganic filler does, basically.
Got it.
You have this inorganic filler. It's mixed in with our organic molecules, and when you put it in the tooth, as it starts to polymerize, because the filler's there, you need less physical bodies. You need less physical molecules to form the polymer.
Okay.
So because there's less molecules forming the polymer, there's less shrinking because there's just less polymer.
Wow.
So because the polymer itself is taking up less space, this shrinking effect is going to be a lot less impactful.
Okay.
So the filler really can help minimize the impact of that polymer shrinking.
And I guess if you're choosing the right filler, it won't negatively affect the strength of the overall.
It positively affects
it. Right. Yeah, that makes sense.
Because the filler is really strong itself, being glass or silica. Yeah.
Right.
So the filler is like, if you could just put plain filler in there and seal it in, that would be great. But there's not really a good way to do it.
Yeah.
So the polymer really holds the strong filler in place.
Nice.
Based on what I understand as a chemist, not a dentist.
Yeah.
And the papers I read, the research papers I read.
Cool. Dang.
Yeah. So I thought that was so interesting.
Yeah. I don't know what I thought, but that's not it.
I thought it was just a polymer. I just assumed they put a polymer in it. And the reason why I assumed that is because I noticed them shining a little light in my mouth. And that is a dead giveaway. And that's what we're going to talk about next.
Nice. Okay.
Before we go into that, do you have any questions you want to ask about what we just discussed about the polymerization and the filler?
Questions I have about the polymerization and the filler. I can't think of any yet. It really is making sense so far.
Oh, good. I'm so glad.
So that analogy helped a lot. So
okay, good.
I don't know if I would have had questions if you hadn't done that, but
thank you. I thought very hard about that analogy. I deleted it and rewrote it 3 times.
Yeah.
So.
No, I don't think I have any at the moment. I'll let you know if I get stuck somewhere.
Okay, great.
Yeah.
So now let's talk about what that little light is for. So far I basically just told you it's in the liquidy state, and then we initiate the polymerization. So then it forms a polymer, right?
Right.
And then your filler is hardened, and yay, that's all good. We haven't talked about why things polymerize yet. We did a way long time ago when we talked about super glue.
Right. What's funny is that I was looking through some of our old episodes to update some stuff on there, and I passed by that one, and I was like, oh yeah, I forgot about this one. Because I think we had that one, and we had a Q&R about some of the questions around it or whatever. So anyway, it's funny that we're talking about this today. But I don't remember what we talked about.
Well, I'll brush you up on just some basics about polymers.
Okay.
So essentially, when you want to make a polymer, there has to be something that will we call it an initiator, or a step to make the different monomers want to react with each other. And by monomers, I mean those individual molecules, those building blocks for the polymer.
Okay.
There has to be sort of like a lighting of the match situation, something to get that reaction going so that they'll all bond together.
Okay.
And oftentimes that is done through what we call a radical mechanism. And I don't know if you remember about radicals, but electrons typically like to hang out in pairs.
Right.
They're like, they want a buddy. They don't like to be alone.
Mm-hmm.
If you have an unpaired electron, it will wreak havoc. That's why we call them radicals, because they act radically.
Right.
They are desperate for a buddy, so they will go steal an electron wherever they can.
Mm-hmm.
But the thing is, they're really just propagating the problem, because they'll go steal an electron, and that leaves behind one unpaired electron in the place they got it from.
Right.
So we have this initiation step where a radical is somehow formed. And then we have these propagations where these radicals they'll go steal a radical, and then that makes steal an electron to make themselves a pair. And that leaves a radical behind. And that will happen a lot. Mm-hmm. So then we have a bunch of radicals all floating around here in this solution.
Uh-huh.
When two radicals find each other, those two electrons can actually make a fully satisfied bond. And as a pair, bonds are typically made up of electron pairs. So when the radicals find each other, that sort of terminates things, that puts an end to it. Mm-hmm. And so you can think of a radical polymerization as something will form a radical initially, the initiation step. And then that radical will go react with something else. And then that leaves behind a radical which will react with something else. And that leaves behind a radical which reacts with something else. And so they start to sort of build up onto each other as they continue to react. Mm-hmm. And when two radicals find each other, that terminates it. So the radical initiation is the thing that starts everyone trying to bond with each other. Because before they're just kind of minding their own business. Mm-hmm. Now, I mentioned that there is some other stuff present in our fillings that I didn't talk about. Mm-hmm. One of those extra ingredients is a photoinitiator. Okay. That's what it's called.
Okay.
And that means it's a molecule that will absorb a certain type of light. So that's where photo comes from. Mm-hmm. And when it absorbs that type of light, there's a weakish bond that will break right in half and make two radicals. And those two radicals will go and start the polymer party. I was trying to think of a good analogy for that, and the only thing I could think of is as a grassroots movement kind of that builds up as it goes along, you know?
Yeah, totally.
But so basically they add in these photoinitiators that when you shine certain types of light, and it used to be primarily UV light, but I did see that one will specifically react to violet or blue light. Oh. It can start off the chain reaction.
Wow.
And the chain reaction is what begins everything reacting with each other. And eventually they'll all bond up, and that's when your polymer hardens, is because it becomes one giant molecule with all these small organic molecules linked together.
Wow. Dang.
And that's why I kept seeing my dentist shine a blue light in my mouth.
Yeah.
Because I thought, is that UV light? It's is it bad to look at this light? You know, I was wondering about it.
Right.
But it does look like blue light.
Sunburn the inside of my mouth?
Right.
Yeah.
It just looked like blue light. So I was wondering about that. And it turns out that's why.
Yeah. Wow.
And so that's a little bit of the chemistry behind dental fillings.
Dang. Interesting.
Yeah.
I guess it's kind of the name of the game, though, to be able to have the stuff be like not hardened and polymerized together yet when you don't want it to be yet.
Right.
But then to be able to say, okay, now I want you to.
Yep.
That's it. That's everything. It's like,
yeah.
That's what makes it so dicey, working with any sort of quick drying glue or whatever. You're kind of like, oh, I gotta work fast, but there's a lot of accuracy and importance to the work that the dentists are doing.
Yeah.
That having control over that variable has got to be like everything.
I tried to use super glue. Now, normally I leave the precision tasks to Mason in our household because for precision, I just can't be trusted. And he was like, you'll be fine. And it took me 5 minutes tops to glue my fingers together. From the time I texted him asking him how to do it to the time my fingers were glued together. I mean, like I barely had the thing open and they were stuck.
And you were trying to glue your fingers together?
Nope. I was trying to do something totally else.
Okay,
and
got it.
I was like, I'm never touching this super glue ever again.
Just want to check because I was going to be like, that's pretty good.
No.
It only took you 5 minutes?
Good.
Oh, okay.
It was not good. Fingers glued. So then as I was reading this, I was thinking, oh yeah, like they get it where they want and then they initiate it with the light. Okay, but there's another kind of dental filling that the reaction starts to initiate. You have like two separate things, and when you mix them together. The reaction starts to initiate. And I was like, the clock is ticking for that one.
Yeah, that's scary.
That's high pressure. I'm like, wow, dentist.
Seriously. Unless it's like, okay, you put the one in there. They probably get it, they get their technique down really well. But like, maybe you put one in there and you have all the time in the world for that one, which might be kind of nice.
Well, the paper I read said that they typically come, in two separate tubes and they mix them on a glass, something like outside of the mouth, and then they put it in
they don't
there.
do it in the mouth. I see. Interesting.
Maybe I can ask. My dentist is also a friend of mine that I went to college with.
Right.
Dentist Melanie. So
that's your usual dentist, not the one you're able to go to on the road.
No,
right?
for the root canal,
you had to go somewhere.
I went somewhere else. Yeah,
near you where you were.
I know. I came back to Denton, but no spoilers.
Really?
Yeah.
Oh, yeah. I didn't know that. I was going to say something. Oh yeah. Well, that kind. I initially thought that was going to be the way that this polymer worked, the two mixing things together.
Yeah.
Because that's like there's a lot of like epoxies and stuff like that work that way. For like wood working and that kind of thing. Even some of these for cars like JB Weld, there's 2-part kinds for that sometimes. So I assumed that was going to be the case. Then I was like, but why would you need the light as well?
Yeah.
And that makes
so they're two different
sense, different kinds. But yeah, if I were a dentist, I would definitely go with that light kind.
Yeah, me too.
For sure. So
there also dental cement is I assume it's also polymerization, but that also comes in two separate ones and you mix them together. And I had a temporary crown on my root canal, a different root canal. Actually, I've had a bad year for teeth. I'd never had a cavity until a year ago.
Dang.
It went crazy. But she gave it to me. Okay, so if anything happens, here's a little bit of like a kit that you can repair it with. And here's a dental cement. You have to mix these up. And I was like, this has got to be a polymer reaction. So that kind of started my curiosity about it. But so dental cement does something similar as well.
Nice.
Cool.
Cool. I feel like we got really to like the root of this chemistry lesson.
Okay, well, do you want to get to the root of explaining it back to me?
Yes, I do. So
I wish I had been I wish I could have done a better pun back, like the root. And I'm like, oh, well, the canal of explaining it back, but I couldn't come up with anything good enough.
I can now always try my best to explain it back to you.
That was so silly.
Okay, let's bite into this.
Okay. All right. Yeah. Let's bite into it. Yeah. That's how I should have started the episode.
That's good.
Let's take a big old bite out of this. Okay.
So teeth are bones that we eat with. I'm just kidding.
I mean, kind of, yeah.
Back whenever my friend Jason and I did Podcast for Your Life, we talked about teeth at one point, and the way we did that was so unscientific. And we're like, are teeth pretty much bones? It's like saying teeth are bones is just like a funny thing.
Kind of seems like it. They hang out in your skeleton after you die, right?
Yeah. I think, yes. At least I haven't seen a skeleton in real life, I don't think. watched on TV.
Dentist Melanie is usually a good sport, so I bet I could ask her. Asked her a question about brushing your teeth after you've eaten once, and she got back to me quick.
Nice. I might have some questions for you to ask her too.
Okay.
I've met her a handful of times, but not enough to bug her with dentist questions, you know. Okay, so when we get a cavity, it is that there is stuff on our teeth that the bacteria are eating. And
like sugar.
And when they eat that, they're not actually straight up eating our teeth. They're creating an acid that burns through our teeth, kind of, right?
Yeah, it kind of weakens it. Yeah.
And so what dentists have to do is first just drill that stuff out, get all the traces of the bacteria and the damage is done, kind of cleaned out. And
it has to be dry. I forgot to mention that. But
dry.
for the polymer to fully bond, you can't have any moisture in there.
Dang, that's why they make your mouth a desert. Interesting.
Not just to torture you.
Yeah. I mean, it's certainly a fun experience for sure. It's like, yeah, this is what it would be like if my mouth was a desert. If I had just eaten a bunch of sand, this is how I'd feel.
This is making me thirsty.
Yeah. So, and then they get that cleared out and get it dry. And then it's polymer time, but we couldn't just add a polymer in there because of that shrinking effect. What did you call that?
Polymerization shrinkage, I think, or polymer shrinkage, something like that.
You know what I immediately thought of is like almost every glue shrinks when you use it. I'm sure that that's similar. Not every glue, like there's some glues that specifically expand to kind of fill a space that I've used before. But I've noticed most glues have a kind of shrinking effect as they dry. I just kind of thought like, oh, there must be some water that's evaporated out or something like that. But probably the same thing.
Probably so, know? Yeah.
So it shrinks, which one...
That makes me wonder, like, what is Elmer's glue, you know? We've done super glue, but what's, like, school glue?
Yeah, okay, Elmer. Okay.
All right.
So they can't just do that because that would potentially not quite fill the shape that they're trying to fill, and also might pull parts of the tooth together in a way that puts it under some strain. Both things are pretty important because they obviously try to match the shape of the tooth so that your bite's similar, and then also, of course, they don't want to put your tooth under strain. They've just kind of had to take a chunk out of it in order to put the filling in the first place.
And if there's any holes between the filling and the tooth, bacteria gets down in there and will keep, Yeah, that'd be awful. It could be even worse cavity than before because it'd be like kind of hidden. Yeah.
So they have to, they put in do you call it filler stuff? What did you say?
They put in, inorganic filler. So that's
inorganic filler.
Silicon and oxygen.
Yes.
And the monomers together, or the molecules together.
The molecules together. So you're not polymerized yet. It's monomers and the inorganic. So the monomers are organic. And then the inorganic filler molecules, which are the silica type of stuff, or you see ground up quartz or something like that. Yeah.
And just to revisit, organic means carbon based and inorganic means no carbon. So the monomers are made up of carbons with a little bit of extra stuff around them. And then the filler is made up of not carbon, just mostly silicon and oxygen bonded together.
And so that takes up space once it's polymerized. One of the mental pictures that came to mind before you used your analogy earlier about like the party and first people mingling and then them linking arms, but also the party with the tables. I was thinking about like a mosaic where it's like you have like this assortment of a bunch of chunks of, pretty stones or
that's really
crushed
good.
up tiles or whatever. And it's like, then you can put it in a cool arrangement, but it's not going to stay like that unless you filled in all the gaps. But also, if you just put like, I guess it's like grout or cement or whatever, you just do that, that doesn't make a cool mosaic. So this kind of has the visual element of like, obviously the point of doing a mosaic is like an art piece. But the fact that you get to fix the things in place that make up your mosaic when you have that filler all around it, and you need them both. You couldn't just have one or the other.
Yeah, that's a great analogy.
And so it's like those inorganic fillers get to be that like those pieces of the mosaic, the like pieces of crushed up small pieces of tiles or rocks or whatever.
Right.
And then the organic monomers that become a polymer later are like filling in all around it. But it's like this huge 3-dimensional mosaic at that point. And those help take up that space and keep the shape that you want in the first place.
Right.
Just like a mosaic. You put these things in place and you want them to stay like that. So it's like you want this to stay the shape of the tooth, fill this hole the right way and not shrink, and have the strength that both polymers are strong, obviously, and then these inorganic fillers are super strong materials as well. And so then you get this really good strong filling that won't change its shape, won't shrink as it cures or whatever.
It does a little, but it's a lot less.
A lot less. Okay. I guess enough to not matter.
Yeah.
Oh yeah, and then but then the way that the monomers have a reaction to turn into a polymer is that they have mixed in there with it, right? You said is the photoinitiator, which I almost said this, but I didn't want to stop you while you're explaining it. But as soon as you said photoinitiator, I was like, I think every family has one of those, you know? It's like Aunt so-and-so is our photoinitiator. We cannot all get together without her saying, okay, everyone, go get together, stand by the fireplace, let's get a picture.
That's Mason's mom in our family. If I'm going to see Mason's mom, I'll specifically do like certain self-care things that I'm like, that way I'll feel like I look nicer in this picture because she's going to be taking pictures the whole time. That reminds me, I'm going to see her in a few weeks, so it's like a time to go get my eyebrows done. You know, I'll paint my nails, that kind of thing.
Yeah, my brother's that in our immediate family right now, my older brother. And what's funny is that he also really wants to like coordinate. He wants to do a family picture, like pose for it or whatever. Put the phone on a tripod and take a picture. But he wants us to have kind of planned what we're wearing a little bit.
Outfits, yeah.
And I am not into that. If you try to structure something like that, if someone comes in and tries to impose some structure, you can kind of bet that I'm, if it's not something I think is super important and really valuable, like I'm all for taking a picture for sure. Let's take one. But I don't want to like, oh man, fake it. You know, I don't want it to be all arranged and picture perfect, like a, you know,
like the JCPenney
yes,
pictures.
Exactly. Yeah. You know, wearing turtlenecks and posing in like a fake, you know, photo set or whatever. And so I will, my wardrobe is already pretty plain, but I'll intentionally go to whatever family gathering we have with no real good picture taking option.
Oh gosh.
Yep. Just like, so it's like, why don't we just wear what we're wearing and go stand at the house that we're staying at and just let the memory, like when we look at the photo later, it'll be like, oh, that's where we were and that's what we were doing, you know?
Well, Mason's grandfather will usually, he like wants everybody to take a picture in a shirt from the place we're at. And so he will sometimes pay for everyone to just go get a shirt.
Wow.
In a certain color. So everybody goes in the color. But you can pick, your family can pick, or you're, you know, like even like me and Mason are married. So it's like, you two can just pick one, or you can go with a bigger family unit if you want. And then you can pick the style you like. And it's like a comfy shirt if you want it to be. And it's flattering. It's like in the type of shirt you would keep wearing. And I do appreciate that.
That's cool. And like, there's sometimes like a level of like, do something kind of cheesy with your family.
Yeah.
That's fun. And that seems like cute. A cool way to do it. It's like, hey, get a shirt from, you know, South Padre or whatever.
That's exactly where we've gotten a shirt from before.
I think that's cool. I think the other thing that I don't always love is that my older brother's not going to listen to this. So he'll be like, bring something like beige. I'm like, yeah, I don't have anything beige. Like, I'm not going to go buy something beige, you know? Like,
that's funny.
It's just like so anyway.
You're like, I'll bring these color shirts because that's what I already have. And you can put around that or not.
Yep, exactly. And yeah, you can wear whatever you want though. I'm not going to care what you wear, you know, go for it. And if it doesn't match with what I'm wearing, I don't care. Okay. So the photo initiator.
Yeah. Well, that was a big old tangent.
Yeah. The aunt or the older brother.
If you enjoyed that little dally off into talking about photo initiators, join the community because that's a lot what the bonus podcast is like.
Yep. And yeah, we just let the whole thing is a tangent, you know?
Right.
About real stuff in our lives. So that photoinitiator, either like a UV light or just like a certain color of light that photoinitiator is sensitive to, will, when it's exposed to that, it'll break a weak bond.
It's enough energy to break this bond that's weak.
Right, because light's energy, right? So breaks this weak bond. So it sends 2 solo electrons out. They were bonded. Now that's broken. Sends them out. They are radicals. They do not like being alone. So they keep finding electrons they can bond with and stealing them from whatever thing they're bonded to.
Yes.
And causing this kind of sudden commotional chaos of stuff.
Yes.
Which then causes, so these are all these monomers, right? So as it's doing that, and then whenever electrons that are radicals find each other, they bond. And it's this time a stronger bond than the photo one before, right? The photoinitiator one before.
Yeah, it would be an actual a strong bond will have formed, not just the photoinitiator. Yeah.
Strong bond formed. And so it just goes and does that.
Exactly.
And quickly, I mean, what are we talking? Like a couple seconds or something, or what?
No, I think it can be like up to a minute. I think it depends.
Cool. Okay.
I don't know. I mean, I'm not a dentist, but I feel like it wasn't like quick light shine. It'd be like they'd shine the light, and sometimes the light would go for a certain amount of time, and then they'd shine it again in there. So it's like 2 rounds of curing or whatever.
Yeah.
Yeah.
Interesting.
And they have to do it in really thin layers because that light can't penetrate very deeply.
Okay. So, this makes me think of is I've seen videos where people like set up stuff where it's like a bunch of magnets, but they're not close enough to each other.
Yes.
And then they'll throw like one in there, and it like just goes and like all these magnets. And sometimes they'll form like in one of the ones I saw, it just like they were set up where they would actually form a really long like stick of magnets.
That is a great analogy.
So all you need is to like throw one in there and kind of destabilize this like thing, and then they all link together.
Exactly.
Because they kind of want to anyway, but they just nothing has started that.
Yeah, these are, and I will say that the specific monomers is not just like random organic molecules. They are individual organic molecules that are prone to link up in a specific way. They will bond together in a specific way, and there's a lot of nuance that we didn't cover in this episode, but you can kind of tweak which ones you use as like how many carbons come off of it and which ways do the carbons come off of it, to try to minimize shrinkage. But then if you get bigger, more branched monomers, that's harder to get them liquidy at the beginning. They're too thick. So then that's like a drawback because you want them to be able to cover the surface of the tooth. And so there's really a lot of nuance in getting just the right mix of like, okay, and what particle size do we want that filler to be? Do we want it to be this big or that big? And so there's a lot of mixture and nuance to get a filling that is exactly right chemically.
Wow. Dang, that's crazy.
Yeah.
Did I get everything?
I think you did, yeah.
Nice.
So that's fun. Okay. And we decided that instead of doing happy things at the end of our episode like we used to, since we kind of have the community for that, we're going to do a relevant category. And I completely stole this from another podcast I listened to called Tooth and Claw, which I love. So you can go check it out. But they sometimes do a category which is like today's topic in pop culture. And so stealing from Tooth and Claw, what is your favorite dentist scene in pop culture? And I wanted to, y'all can message us this or comment it to us.
Yeah.
I wanted to give Jam some time to think about it. So I messaged him this earlier today. And Jam's not a good texter backer. And he messaged me back so fast. I was like, hey, just be thinking about this. And he was like, I know what it is already. In like 30 seconds, text back. And I was like, okay, I'm ready. So what is it? What did you think about immediately?
Okay, so which show do you think I played?
Seinfeld.
Yeah, 100%.
Okay, I knew it.
I forgot his first name. There's a dentist in the show that comes in and out. He's not like, I love how they do this in this show because there's characters like that that exist in the Seinfeld universe, and you just never know when they're going to show up. I think his last name is Watley, but I can't remember his first name.
Okay.
But it's played by Bryan Cranston from your favorite chemistry show, Breaking Bad. So early in Bryan Cranston's career, pre Malcolm in the Middle.
That's not my favorite show. I just want to point that out.
Yeah, it's her least favorite. But so there's this.
I'm looking it up.
He's several times. Tim Watley. Yeah, I was close. I knew the last name. So he's in this several times. I think it's like the third appearance he's in. They're getting something done where he has to go under. And so Tim Watley asks his assistant, is like, can you prepare the nitrous oxide? Because whatever it is, he has to go under. And so she hands Tim Watley the mask thing, and he goes... and then puts it on Seinfeld, and
so
you can
for
see
people listening, not watching, he put the mask on himself and takes it.
Yep. It takes a little huff of the nitrous oxide before putting it on the actual patient to test if it's good and
that
potent
he's about
to operate on, do a root canal or something on, and so he's getting a little loopy himself before doing something.
Just take the edge off.
Yeah. And you can see Jerry Seinfeld getting visibly like, wait a second, what's going on? And then of course he quickly fades out and falls asleep or whatever. But I said the one reason why it's one of my favorite moments from pop culture too is that I watched a lot of like behind the scenes Seinfeld stuff, and the actor playing the dentist, Bryan Cranston, did not tell Seinfeld was going to do that. So it's like really good. Obviously that wasn't
like
real.
An ad lib. Yeah.
It wasn't a real, obviously it wasn't actual gas coming out of that, but so him doing that was a joke he added in. It's a very Seinfeld joke.
That's also a very Jam joke.
Yes.
That's like very much your humor.
Yes, definitely. So I loved that episode. And I remember finding out later that was ad-libbed by Bryan Cranston.
That's a good one.
It's genius. Like it's such a perfect little detail to like, as you're fading away, about to go under, to be worried about, is my dentist about to botch my, and how often does he huff this stuff during the day?
But also, I can't be bothered because you're under.
Yep, you're gone. It's too late now.
That's a good one.
So very funny. That clip's very widely available. It's certainly funnier to watch it than to hear me explain it. But anyway, go look it up on YouTube. But that
detail was good.
There we go. Yeah. Now people will appreciate it more. It would have been a passing moment in the episode has now been analyzed in detail. What's yours?
Well, I have an honorable mention because when I asked this question to two other people, they both said the same thing, and I thought it, but it wasn't my favorite.
Okay.
It was Finding Nemo.
Oh, yeah.
So many scenes in that one, but like, when the little fish are on the instruments or when the guy, he's distracted. And I thought of that one first. So that's why it's my honorable mention. But then I thought of another. It's not exactly a dentist moment, but in Parks and Rec, when Ron Swanson is in the meeting with a bunch of other people and he pulls his own tooth and everybody freaks out, and then there's like cuts to him by himself. He's like, the dentist pulled it this morning, but I just had to have a little fun with it. I thought about that moment a bunch when I had my last dental thing because I was like, I would love to pull my own tooth out right now. That must feel really good. So anyway, that was that was the thing I kept thinking about.
That's a good one.
That was a good one.
I forgot about that. I need to rewatch Parks and Rec at some point.
It's been a long time since I've watched it.
Yeah, same.
So share with us your any of your fun dental and pop culture moments so that we can enjoy them also as we think about the chemistry of dentistry.
Yes, please. Thank you for teaching us about the chemistry of dentistry.
Yes, thank you for letting me teach you. It was really fun.
And if you have questions that have come up from listening to this episode, things you've wondered, is this chemistry or what about this chemistry of dentistry or something like that, or anything else in your life that you think could be chemistry, please ask us. Send those questions to us on our website at chemforyourlife.com. That's chemforyourlife.com to share your thoughts, ideas, questions. If you'd like to help us keep our show going and contribute to cover the costs of making it, you can join our super cool Chem community like our friends we mentioned at the beginning. You can get perks, notes, behind the scenes stuff, ad-free stuff, version of the show, all that kind of stuff. We'd love to have you join our chem community and get to know you better. And you get to support the show and keep it going, keep it free. If you're not able to do that, you can still help us by subscribing at your favorite podcast app, rating, writing a review on Apple Podcasts and Spotify, as well as subscribing on YouTube and throwing a comment on one of our videos over there. Those things help us to keep our show going, help other people to find the show, and share chemistry with even more people.
That's right. This episode of Chemistry for Your Life was created by me, Melissa Collini, and him, Jam Robinson. Jam Robinson is our producer, and the episode was made possible by our financial supporters on Patreon that we've mentioned a few times today. And really thank you all so much for giving up your hard-earned money to try to help make this show more accessible for even more people. And so we'd like to shout out those listeners and those supporters. They are Chelsea M. Welcome to the club. Dorian V. Welcome. Scott B. Another newer member. Jesse R. Sierra L. John T. Avishai B. Bree M. Brian K. Carol R. Chris and Claire S. Chelsea B. Derek L. Elizabeth P. Emerson W. Hunter R. Jacob T. Christina G. Katrina H. Latila S. Lynn S. Melissa P. Nicole C. Rachel R. Sarah M. Stephen B. Suzanne P., Timothy P., Venus R., Erica B., Cullen R., and Jeanette N. It is so fun to have so many people's names to read. That's really exciting. And thank you all again for everything that you do to make this show happen. And extra special thanks to Bree, who sometimes also makes illustrations to go along with our episodes.
And if you'd like to learn more about today's chemistry lesson, you can check out the references for this episode in our show notes or in the description of the video on YouTube. And yay, chemistry!
Yay, chemistry! We're back! That was fun.